Okay, so during this video I will want to talk about the basics of mating within Catia V5. For this example I have this caliper model. It's in a step file format. Also the link is below in the description on Dropbox, so you can follow along. Okay, so let's see. I have the model. I can zoom to fit all, so I have the rotation pivot in the middle, and I see that the caliper, it's an assembly and it has 17 elements to it. Okay, so the first thing I will want to do is to define the fixed component. So I will choose fixed component, and for this caliper the fixed component will be the larger part. It's called base, and I will click on it while having the fixed component pictogram active. Now if I go to the constraint within the tree in the left side of the screen, I can see that I have that fixed one component. It's the base of the caliper. Okay, now I would like to make the components so that if I translate this lock, also the screws will follow along that component. So I'll go to manipulation. I will set that I want to drag along x-axis, and I can slide that part. Okay, initially I don't have this with respect to constraint check on because I don't have any constraint defined yet. So okay, so the first constraint will be a coincidence constraint. Now in order to get the axis of the thread of this screw, as you can see from this zoom in level, it's a bit harder to find the axis. But if I will zoom in a bit more, if I go on the extruded area, I will get the axis every time. So I won't go over here where I can touch the profile of the thread with the mouse cursor, or I can select it, either the edge or the surface. I will go on the inside area of the thread. Okay, so I want this axis of the screw to be coincident with this one. I see that the software has made that link, but it's in gray, it's not with green. So I can either go to update all on the bottom of the screen, or I can press the default hotkey Ctrl plus U in order to make that coincidence updated. To make things faster, you can go to Tools, after that Options, and over here we will open the Mechanical Design section and we'll go to Assembly Design. And over here we have the Update section. So I will go to Automatically. Okay. And I will have that checked. Then I will close this and I will start to do the other mates. Over here, for this screw, I would like to define, let's say, the distance until the lock. So I will go to this one, offset constraint, if I want to set a specific distance between the two components. If I want them to be closely tight, let's say we can use contact constraint so that there won't be any dimension between those two, any value. It will be 0. I can do that with either coincidence constraint by selecting this surface and the other surface. As you can see, the two surfaces will be coincident. Or I can go with contact. It will do the same in this situation. So I want a contact between those two surfaces. But if I want to set a specific offset dimension, I can go with offset constraint, and I can select from the top part to the lower one. I want to have 1 millimeter. Okay, and now if I go and measure between the bottom side of the screw to the surface, I will see that I have 1 millimeter dimension. So now let's do the other coincidence. I will use again the coincidence constraint between this smaller screw and its axis. Now if I want to define the exact position, now if I would start to manipulate with respect to constraint, and I will move this slider, I see that the elements are following along. But if I will go and I will move this on I can see that I can move this along because it doesn't have any coincidence between the base of the caliper and the lock. So I will fix those now. I will press OK. I will go to coincidence constraint, and now I can do this in multiple methods. I can either go for surface, or I can go for edges constraint. For this model, I will go for, let's say, this interior edge within the lock. I will want it to be coincident with the top edge of the caliper. So the automatically updated part assembly went in, and I can see now the model is in position. But I need to define another constraint. If I go to manipulate, and I will try to manipulate on X, drag around X axis, I will see that I can still rotate this piece around the base of the caliper. So in order to fix this, I will need to define another constraint. I will go to coincidence constraint, and I will set that, let's say, I can either choose this interior face to be coincidence with this one, orientation opposite. And now if I try to manipulate it again, let's say manipulation, with respect to constraint on X, I won't be able to move it. But if I want to drag along X, I can move and slide this lock on the base of the caliper. Okay, so let's see. I see that the screw isn't in position. Now if I rotate it, let's see exactly where that screw went. Okay, so let's see. Is it hidden? No, it's not hidden. Let's reframe everything, and over here we have the screw. It's on the top part of this viewport. Okay, and I need to define a coincidence for that also. So firstly, I can either decide to manipulate this. Let's say move it a bit closer. If I go on X, it won't be the proper one. On Z axis, I will need to slide this to the bottom part. Okay. In case you have this issue and one of the element is so highly translated from the model, you can use this exterior compass within Catia. So if I will select this and I will position it on a flat surface of the model, even if you don't position it on a flat surface, you will still be able to move it, but it's best to position it on a flat section. And now I can translate it towards my model. So let's see, I will drag it like this. I see that the model is rotated, so I will do a rotation. Let's see the exact axis that I want to rotate. It will be along the bottom one. And now I will press an update. Now I can select the red dot within the compass, and I will left click the compass anywhere in the viewport, but not on a part. So over here on the background, I will left click it, and it will automatically reposition in this section. And now I will define the constraint for this one. I see that the rotation pivot is not optimal now, so I will go again, reframe all, and now it will be centered within the middle again. and I will say that I want another coincidence constraint, and I would like this surface to be coincident with this one. Okay. Now, if I would like to define, let's say, this surface, this interior one, to be parallel with this one, I can add another constraint. I can go to angle constraint. I will select that surface and the surface for the parallelism coincidence constraint. Okay. I will want it to be opposite. I can already see in preview that the screw align itself so that it will be parallel to that area. And now if I will want to manipulate this lock, it will work with the other components. Okay, so I can translate it along the base of the caliper. So in order to fully define all the constraints for this model, I will define the other constraints. So for this bottom roller part, I will want this axis to be coincident with this one. The model was already positioned by default in its initial status in the STM step file format. And now I would like to position this inside the lock. So I will want this surface to be coincident with this inner surface. Okay, and I have the other elements for the main slider of the caliper. Again, I will want this axis to be coincident with that axis. I will set that same offset, so from this top area until this area it will be 1 millimeter, and I will align and constrain the screws. So firstly, I know that the z-axis goes up for this model, and I will say that I want this axis to be coincident with that axis. Also, I would like a coincidence between the bottom surface of this part with this one. Again, if I want to add that parallelism, if I want it to be perfectly aligned, I can do this and go to parallelism. Okay, so similar with this, we would go along each element. But let's see, now if we try to manipulate, we have this option, is called stop manipulate on clash. So if I start the manipulation, I will want to move this slider, I can slide it like this. But if I have this checked, so it will be orange, active within Catia. If I will drag it, it will sense some collision with the screws over there. Also, if I try to move it back, again, the model will stop on clash. And it will highlight within the element that there are collision between. I can also analyze that at the bottom, so I will cancel the last manipulation. I want the part to go back to its initial state before it has been moved. This usually takes a lot of processing within Catia V5. Okay, so we have that done. I can analyze, it's called clash at the bottom. And I can see between, let's say, all components. I want to check for clashes between the parts. I will set apply, and it will tell me, let's say, the areas where there are some contact. So I can see over here between the slider and that screw. Again, over here I have some clash contact. It's mainly the smaller screws with this slider because I have moved it. Also I have over here, it's called contact, so it's 0 value between the slider and the base. That's okay. And over here I still have these dimensions. Over here there are let's say around 5 millimeters interfering between those two parts. Okay, so I'll click OK, and we will put all the coincidence for this part. So let's see, we will start with these elements. I will go on I will firstly drag that smaller screw, and then I will put the coincidence. So between this part and that one, also I would like to select the surfaces. So I would want the screw this section to go up to this section, and also I would like this surface with this surface. Okay, I won't go with that with coincidence. I wanted to put angle, so for that perfectly aligned parallelism. Okay, so every time you have some errors, try to stop, try to resolve them. You will see a smaller circle underneath it, and at update it will tell you that there are some problems between those coincidences. So try to fix them. Okay, so for example, if I try to set, let's say, for this screw, an extra constraint with this one, it will go like this, but that's mainly because the slider doesn't have any constraints yet. So it will force that. Okay, so let's see, I will want to drag this around, firstly on z-axis, so I can position it better. So I will want the sliding edge to be coincidence with the sliding edge, and I will move it again. Let's say I will rotate it now, or I can go without respect to constraint, keep it like this, and position the less constraint. So this surface, for example, will always have to be coincident with that section. Okay, and I still have the smaller screws. For this assembly, you are not, let's say, required to do all the mating, but later, when you will use digital mockup with DMU kinematics, it's really important to have degree of freedom going to 0 in order to have your mechanism working. So we will take a look at that section also, but firstly I want to present the basics of Catia assembly, and for that we have this model. So I want this surface with that one, not with the coincidence, with the angle. So I see that it has that update cycle. If I will try to press Ctrl U, go to update, it will have this diagnostic. The system is constrained is inconsistent, or over constrained. In our situation, it's over constrained. It can't respect all those constraints. So I will delete 26 because it's the last one, and I went with coincidence constraint, not with the angle one. And I will apply the correct one now. So I want them to be parallel. I will go to the next screw. So let's say this on Z, this on I, and I will select the axis. I will select the surface, or I can go, let's say, yeah, it's best with the surface. It doesn't allow me to get that boundary. And I still have the last one for parallelism. So I want that one and that one to be parallel. And I have this axis and that axis. So this is quite repetitive for this model, but if you are just getting along with Catia, I really recommend you to do all the model so that you get some better practice at this. So I want that and that one to be parallel. Okay, and I still have one more screw. I see that this one doesn't have the fully defined, only the axis is defined for it. So if I will try to move it, it doesn't have the surface, it only knows that the axis is coincident with the inside axis. So I will position this now. Okay, I already have that axis. I will go to the surface. So this surface with that surface. And let's do the angle constraint for this one also. I can choose either of those faces, and I can go to parallel, and I can see that the axis is not defined, so it wasn't there, that constraint, but now if we position it, it should be all good. I will do an update, and I see that that coincidence is fine. I will go now and let's say move this on y-axis and do the last one. So the last small screw of this caliper model will be this and this, and we have the coincidence between this surface and that surface. And now the last angle constraint, it will be within this one and the bottom part. I want them to be parallel. Okay, so now if I will try to manipulate this, if I will move the lock on X, or I can move the slider, I see that I still have one screw left over. So let's do this last screw also. So I want the axis of the thread with the axis of the hole. I will also want to move it a bit out, so it's easier for me to select that surface. So I want that area with that, and the last angle, let's say this one with this one. Okay, I don't want the edge, so I will delete that. It doesn't allow me to right click it there, so I will just have to do it again. I'll just choose a surface, this one. Now it's plane parallelism. Okay, so if I manipulate it, I see that there are no clashes. That's because I don't have this stop manipulate on clash. Now if I will slide it, it will clash. So this was the first element that highlighted in orange, indicating that the model is clashing over here on that bottom section. Okay, as you can see, that's the first section that is being in contact with this. If I would like to join them together, so that when I move the slider, also the lock moves it, I can add this constraint. So let's see, it will say that, okay, so I want to position that surface with the inner side, but it won't go all the way, so I will do an offset between those two. Offset that and that, let's say 1 millimeter. I will go a little bit lower, 0.2. If I will analyze for clash, let's say I see that the screws are clashing. That's mainly because, okay, so over here we have this clash, it's 0.085. So all the screws are having mostly -181. That's mainly, let's say, an interior clash. I will do some sectioning within the caliper to see exactly that clash. So if I go to sectioning, dynamic sectioning, I will want to rotate this. Let's say within the section of a screw. Here we have the screw over here. Let's see if we will add some transparency to the slider. So go over here. If you don't have the graphic properties, you can activate it like this, graphic properties, with right click. And I will go to the opacity. Let's see exactly what's clashing over here. I will edit this part, so it's called slider. I will edit in new window, and let's see. So the cutout is through the whole model. Maybe there's a bit of clashing over here between this surface and this surface. It's 0.711. I don't see. Yeah, there's that inner cut. You can see that inside. So I can make the slider model, the cut a bit larger, so I don't have that collision. But since this model wasn't created within Catia, let's see. So this will be that area. If I will check the diameter, it's 0.762. I will create a circle. I will hold Control. I will make them concentric, and I will make this cut larger. So 1.6, maybe even more, like this, and I will cut it. Okay, now there's more room over there. If I will update it, and I will do a clash between that one and that one. So I want it to be between screw and the slider. So I want a clash between two. Selection 1 will be the slider, selection 2 will be the screw. Okay, so I still see that there's a clash of this value. So let's see exactly where's that clash indicating. Okay, it's pretty odd because there is no clash, but maybe since the model is imported from a step file, it wasn't originally created in Catia, it has this issue. Okay, let's just try to do a bigger cut to see if there are any other clashes between those. I will just do a roughly large cut. Let's say 2 millimeters. I will pocket that, and I will go back to the caliper. It should be updated now, so I want this to go again like that. Okay, so yeah, this is the issue. I did all the cutting and the analysis for that one while I adjust the model on this part. So now I can see that there shouldn't be any clashes over here. So it will be this for the dynamics clashing interaction between two components, this and the slider, but it didn't select them correctly, so I will reselect them. I want to see the clash between two selection. So first it will be the slider, the second element will be this screw, is called screw 2. Okay, so there isn't any clash. Okay, so I can verify if there are clashes like that. Here is a section where I did that cutout, and the other one don't have it. So there are some clashing within the inside of the hole. Okay, so that's mostly, let's say, the basics within assembly design in Catia V5. You can download the file and you can try it yourself, see exactly how you can assemble parts and how you can check them for clashes. Okay, so I hope that this video helped you. See you in the next one. Bye bye.